Hey, what's up guys? This video is for section 9.3, which is transformations of quadratic functions. And we're going to start looking at a different way of writing a quadratic equation. The name of this form is the vertex form, and you guys can see it on the screen. Here I have f of x, this is the name of the function, f, equals a times the quantity of x minus h with the squared plus k. If you guys want to compare with the standard form has an a, x squared, but then it has a bx plus a c. We don't have a b or a c in this form. We have what is called the h and the k, and I'll go over what that is. So when you guys have the vertex form, this one is actually a lot easier to graph than standard form, because the vertex form, just like the name says, vertex, it gives you guys the vertex in this equation. And like I said, I'm going to explain that in my other videos, how to graph in vertex form. But right now in this video, I want to show you guys what those values means, because when you guys have a vertex form, you guys are going to change the parent function. You guys are going to transform the parent function depending on the a value, the h value, and the k. So let's talk about what is a transformation. So a transformation of a parent function is when a graph or the shape of that function or that graph is going to change in size and or in position. Now, shapes can be anything. You guys can have a triangle, you guys can have a square, you guys can have anything else, but we don't do those here in Algebra 1 or Algebra 2. That's more for geometry. In Algebra 1 and Algebra 2, we talk about functions. So we have a parent function for quadratic functions, a parent function for a linear function, and in Algebra 2, you guys will learn that we have more functions, cubic functions, and absolute value functions, and there's more. But you guys can transform the parent function. Now, going back to the parent function, a quadratic equation for the parent function is f of x equals x squared. And I put that on the right side of the screen because this equation or this function only has an x squared. It does have an invisible 1 as your a value. Notice that the a value is always in front of the x squared, or the one with the square. So you guys have the a value equal to 1, but we don't have anything else, h or k, or you guys can also say we don't have a b or a c. So this is the most basic function, parent function for a quadratic equation or a quadratic function. Now notice, if you guys look here, f of x has more things. First of all, you notice that we have a parenthesis for the vertex form, only one parenthesis with the square. Every quadratic function must have a square somewhere. So we have a square here, because it is a degree of 2. We do have an a value. The a value can be an invisible 1, just like this one here. So you guys have a value. But in vertex form, you also have h inside the parentheses and a k outside of the parentheses. So this vertex function is different from the parent function because we are going to have those components. Now, when you guys change the size or the shape of this function, you guys are going to say we are going to stretch the function or we're going to compress. Now, you guys can also change the position. When you change the position, we say you translate the function. Now, how do you translate? When you move in a quadratic, a coordinate plane, you guys move to the left, to the right, up or down. Now, translating, that's what it means. You guys are going to move somewhere to the left or to the right, or you're going to translate somewhere up or down. Now, let's go ahead and look at those components. First, let's look at the h value. So I have an h right here. H is in horizontal translation, which means the graph will move left or right. Now, it says here that you guys want to always change the sign of h. So that means when you look at the h, let me underline that for you. I have x minus h. So when you guys are looking for the h value, whatever sign you guys have here, you're going to take the opposite of that sign. So even though you guys have x minus, let's say, a 5, x minus 5, your h value is not going to be negative 5. It's going to be positive 5 because you guys need to change the sign. You take the opposite of that value. Your k. Now let's look at k. K value, this one here, is your vertical translation, up or down. Now let me underline something else. Never change the sign of k. K, it's outside of the parentheses. Let me underline that again, right here. And you guys do not have to take the opposite of that value. So k always stays the same with the same sign that you guys will have. So if k is plus 2, k will be positive 2. If k is a minus, let's say you guys have a minus 7, then k will be negative 7. So never change the sign of k, but for the h, you always want to change the sign. You take the opposite of the value. Now let's talk about the a value. Now you guys kind of already know what happens with the a value here. The a value, if it's negative, you guys know that the parabola is going to open down. If a value is positive, you guys know the parabola is going to open up. And this is going back to the standard form. It is the same thing. When a is positive, it goes up. When a is negative, it goes down. But when we talk about the vocabulary in transformation, we say if a is negative, that is called a reflection across the x-axis. In other words, it goes down. Okay, the fancy way to say it, the mathematical term is reflection across the x-axis. You guys can say the parabola is going to open down, but if you guys want to sound fancy, just say, oh yeah, this is going to be a reflection across the x-axis. That's when the a is negative. If a is positive, there is no reflection across the x-axis. There's not going to be a parabola going down, the parabola is going to go up. Now, the a value, now look at here. When you guys have a number for a, ignore the negative. If you already know that there is a reflection across the x-axis, when you guys ignore the negative and you look at the numbers, just the number, the absolute value of whatever number you guys have, if that number is greater than 1, that's going to be a dilation vertical stretch. Now dilation, that one is kind of more for geometry. They use dilation in their vocabulary. Algebra 1, we don't use that word. We just say vertical stretch or vertical compression, but it is technically a dilation vertical stretch. So you guys will hear me say vertical stretch. I won't use the word dilation, but keep in mind for geometry, you guys will see that word again. So vertical stretch. Vertical stretch, it means that you guys are going to stretch your graph vertically. Vertically means up and down. So imagine like if you guys have a balloon, okay? Not inflated, no air inside. You guys take the balloon and you guys stretch it down and up. So with your both hands, you stretch. That's a vertical stretch. If the absolute value of a is between 0 and 1, not equal to 0, not equal to 1, just between 0 and 1. It can be a decimal, it can be a fraction, but if it is between 0 and 1, we say that's a dilation vertical compression. So like I said, you guys won't hear me say dilation, but vertical means up and down, and compression means that you push, okay? You guys actually compress. So an example that I can give you guys is if you guys have, I don't know, a sandwich, and you guys have peanut butter and jelly sandwich, and you guys take the top and the bottom with your hands and you squish it. That is a compression. You're actually pushing down. You guys have the actual sandwich become kind of like a tortilla. Okay, you guys have a jelly and peanut butter and jelly tortilla. So that is a vertical compression. So today for this video, I'm not going to show you guys how to graph the actual function in vertex form, but I'm going to use the app, the graphing app Desmos, to show you guys how a, h, and k affects the parent function. So you guys see 3 examples here. I'm not going to do all 3, but I'm going to show you guys the one on the right side, p of x. That is the name of the function p, but we do have a quadratic function because the highest exponent, notice here, is a square. Now it says here to describe how the graph was transformed from the graph of f of x equals x squared. Now even though we have a different name up here, f of x, they are saying that this is the parent function. We have a parent function and this function changed to that. So what I'm going to do, I'm going to write the parent function on top of this vertex form and you guys will compare. So I have the f of x equals x squared. So I want you guys to focus on this side right here. So I'm going to zoom in so you guys can only see these 2 functions. And I want you guys to compare the 2 functions. So first of all, f of x has an invisible a equal to 1. It has an x squared. It doesn't have anything else, a b or c, or you guys can say h or k because we don't have parentheses, we don't have anything outside. How is this different from this one? Or in other words, let me say that the other way. How is this function different from the parent function because this parent function was changed to this function. So first of all, we have an a value different than 1. My a value is my -2. So notice we have an invisible one here. Now we have a -2. The h is inside the parentheses. So this one, the parent function doesn't have parentheses, but we do have parentheses here, and that is your h value. Notice what I did here. H equals -3 because I have to change the sign of h. So that's different from the parent function. The k value over here, we have a -5. So k value never change the sign, you keep it the same, and that is a -5. So I put a equals -2. I have my h and my k. What does it mean? Let's go ahead and talk about what this means. First of all, we know that the a value is negative. Just look at the sign, ignore the number right now, just the negative. The negative tells you guys the parabola is going to go down. It's going to open down. Now, the fancy way to say that is this function is transformed by reflection, or it is reflected across the x-axis, which means the parabola is going to go down. Now let's go ahead and talk about the actual number, okay, for a. Now a, it is a -2, but if you guys take the absolute value of -2, that's going to be a +2. You're just looking at the number for a. Since a, the absolute value of -2 is +2, that is greater than 1. 2 is greater than 1. When that is, when the a value, the absolute value of a is greater than 1, we say there's a vertical stretch by a factor of 2. Factor of 2 tells us how the stretch was. So we are going to stretch it by a factor of 2. If the a value, let's say, is -5, your absolute value of a will be 5, and we'll say it is a vertical stretch by a factor of 5. So this number here is your actual a value or your absolute value of a. Now, you guys look at the h. H here, we have x plus 3. I change the sign to negative. That means that we have an horizontal translation. And it's going to go to the left because it's negative. -3 means to the left. And your k value, so here we say translated 3 units to the left. And your k value is -5. Do not change the sign. And this is your vertical translation. So that means that you guys go up or down. How does it move? Well, the graph is going to go 5 units down. Okay, so that is your translation. But this, when you put everything together, is how the graph is transformed. So let me show you guys the parent function again here. So what I'm trying to say is this function, x squared, was transformed by reflection across the x-axis, vertical stretch by a factor of 2, and it's translated 3 units to the left and 5 units down. So let me show you guys decimals. So first of all, you guys see the parent function in decimals. Y equals x squared. So notice my y equals x squared, a is 1. You guys see that the parabola is going up because the a value is +1. The vertex is at 0, 0. Okay, now in this same graph, I'm going to keep this one in red, and I'm going to graph the other function that we just talked about, and you guys will notice how this function is transformed. So now you guys see 2 different graphs in the same coordinate plane. So we have the parent function up here, y equals x squared, and we have the transform function. So this parent function changed to this. So I want you guys to think about the vertex first of all. Let's look at the vertex. So the parent function is right here. You guys have the vertex at 0, 0, which is the origin. The transform function, the other function, is this one here. Now the vertex is right there. We have a gray point right there. So let's go ahead and see how did this vertex move from here all the way to over here. So if you guys look at this one, 1, 2, 3, 1, 2, 3, 4, 5. So that's what is a transformation. So this vertex was moved 1, 2, 3 to the left, 1, 2, 3, 4 down, or 5 down. Let me do that again. 1, 2, 3 to the left, 1, 2, 3, 4, 5 steps down. So that is your horizontal translation and your vertical translation. That's how the graph was moved. Now look at the direction. The parent function is going up, but this function or this graph is going down. And that's because the a value is negative, so we say it is a reflection across the x-axis. Now I'm going to zoom out so you guys can actually see the width of the two parabolas, and we'll talk about vertical stretch or vertical compression. So if you really pay attention to the actual width of the parabola, I'm talking about from one side to the other one. So look at this width right here and look at this width right here. This width is less than this width over here. So that means that this was stretched vertically. It became thinner and thinner and thinner. You guys can say that. Now, in order to show you guys a bigger difference, I'm going to change the function that we have here. So I'm going to go up here and I'm going to change that -2 into, let me try this, a 7. Let's try that, okay? I'm going to put this away. And I want you guys to see the width. Look what happened to the actual width of the parabola. So this width became smaller, it became thinner. This one stays the same because that is a parent function, so it's a regular width from one side to the other one, but this one is here. So what I'm trying to say, guys, as the A value increases, is bigger than 1, increases, it goes up 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, whatever number, the width of the parabola is going to become thinner and thinner and thinner. That is a vertical stretch, because if you think about the balloon in your hands, if you guys have a balloon and you guys actually stretch it up and down, the balloon is going to look taller and thinner. Now what happens if the actual number becomes smaller? Okay, so I'm going to keep the negative, but I am going to change the 7 into a number less than 1, between 0 and 1. So let me try and change that to 0.5. Let's say 0.5. Okay, so let me put this away. So if you guys look at the width, compare the parent function, the one in red. This is the regular width of a parabola. Well, this one looks bigger. Okay, that's what happens when you guys have a vertical compression. The width of the parabola gets bigger. Now let me change that again. Let me put a smaller number. So I'm not going to use 0.5. I'm going to use 0.25, which is smaller than 0.5. So you guys have a bigger width. So this one here, notice what happens here. You guys have the width of the parabola bigger because you guys have a vertical compression. It becomes wider as the A value is smaller, gets smaller, smaller. The parabola becomes wider and wider and wider. But let me go back to the one we have on the actual example. So let me change that to a -2, and then we'll talk about the transformation again. So we have a -2 here, and we do have let me put this away, the keypad right there. So we do have the width of the parabola, parent function up here, and the width of the transform function. So I'm going to make these smaller so we can actually read again how the vertex or how the parabola was transformed. And using decimals, I show you guys how that parabola was transformed. You guys have the parent function up here, y equals x squared. You guys have the transform function, y equals -2, parentheses, x plus 3 squared minus 5. Notice that I'm not using p of x or f of x. Those are just names of the functions. When we use a graphing calculator or a graphing app, we use y instead of f of x, or we use y instead of p of x. Okay, so once again, this parent function, f of x equals x squared, was transformed by reflection across the x-axis, vertical stretch by a factor of 2, translated 3 units to the left and 5 units down. Okay, so I want you guys to really understand this section or this video, because the next video is going to show you guys how to graph vertex quadratic equations in vertex form. So if you guys understand transformations, you guys will have a better understanding, and it's going to make your life a lot easier when you guys have or have to graph quadratic functions in vertex form. So guys, I wish you guys the best. I want you guys to practice all the time, and I'll see you guys later.